we can make $7 million a month or $100 million a year, keep recuperating back into the ecosystem, and the loans are paying themselves off. Yeah, I'm Jagdeep Sidhu. I'm a Syscoin co-founder and been in the space for 10 plus years. Syscoin is one of the original cryptocurrencies, probably 20th or so cryptocurrency ever made, focused on being a Swiss Army knife of value. It's a layer 1 blockchain, so it's like Bitcoin, it's like Ethereum, it's kind of both of those put together. We've been really deep, and the reason maybe people haven't seen us too much face to face is because we've been really deep on the research side for a long time, and we offer the data availability on layer 1. We can go into what that means, and you can consider us the only other modular blockchain besides Ethereum. There's no other one like that. Modular blockchain means you have a roll-up centric roadmap, meaning when you want to scale the blockchain, you have to avoid every node recomputing everything, right? If you avoid recomputation, then you can solve the scalability problem. In order to avoid recomputation, you either have the option of a ZK-Rollup, it was Plasma at first, then optimistic rollup, then ZK-Rollup, right? The benefit of optimistic versus Plasma was that it inherits the security of layer 1. Plasma didn't. In Plasma, you had this big attack vector that if the Plasma operator took off, potentially all the money's frozen. But what the optimistic rollups did was, let's put the data of what everyone's doing transacting, small amount of data, 130 bytes per transaction, back into Ethereum in a really cheap call data. It's not processing it, but it's just storing it. So therefore, if you're using layer 1 for censorship resistance, meaning I can always exit, then you can move the computation off of the base layer. Ethereum is doing this, Syscoin is doing this. Arweave is a data layer. So it's like more just strictly data. There's no notion of computation or smart contract execution. We are talking about data storage in terms of just censorship resistant information. Usually these are accounts or the base amount of value being sent. Just so if the world blows up, I can look at the blockchain and I can find my own account information and I can exit the layer 2 back to layer 1. Yeah, we came up with the idea of our data availability at the same time as Ethereum, but independently. We didn't know of what they're doing with proto-dank sharding until ETH Denver, but we released our actual research paper like 2 weeks before. We actually thought they were copying us. It was funny, but we realized they're doing proto-dank sharding in the same way. You have to break down. So once you get technically into that problem, you break it down into 2 parts. Data availability means you are using the blockchain to prove the data got sent around. So any researcher will tell you the important part of the data availability problem is the fact that the rollup has sent the data to the world, the right data to the world. He can lie and say it's the wrong data, but the blockchain will catch him if he does that. So the propagation proof that the data has been sent around is the important part. The storage, it doesn't need blockchain because any one person can store the data and reconstruct the proof system that they need to exit. Yeah, so in Ethereum, Ethereum is a data availability credit system now. That's all it is. It has execution storage and all that, but no one's going to be using that. Everyday people, average Joes, are going to be on the layer 2s. And people are only touching layer 1 for data availability. Sharding, all that is doing is breaking up that data availability into multiple chunks. Because they have proof of stake now, they can say, okay, these validators store small amount of data, they break it up. Just like, BitTorrent breaks up the chunks and then you download from the chunks and you assume 50% of the people are available to reconstruct the very similar concept. It's a database theory. But we think, that concept might have some flaws. Because if you're breaking down the concept of data into multiple nodes, the assumption is that 50% of the nodes are online for you to download that data. What happens if the internet is having widespread issues, like they can't access the data, then the roll-up is not secure. So we took a different stance. We said every node gets the data, but it could be deleted much quicker. So in 6 hours it's deleted. but every node processes the data, right? But the way we structured it, it's very, very efficient. So we use 64 megabytes in one block, which is 2.5 minutes, and we've hit our test net. We actually have this concept working, and we saw no delay in any of the nodes. So very, very, very confident this is a better solution, and more decentralized. It will, because you're assuming 50% of the nodes are online. So the more people come online, the more chances of a fault. Every node checks everything in our system, so it doesn't really affect, because like how P2P works in the Bitcoin stack, right? It's mesh network. Even Ethereum is like this. I have a node. I'm a full node. I have 8 other peers. I propagate my information of my transaction, my block, to 8 other peers. They propagate to 8 other peers. That's 8 times 8 times 8 times 8. It only takes 3 or 4 hops to get to everywhere in the world, right? And to attack that system, you have to spam the entire network and keep spamming it, and it costs a lot of money. Because of proof of work, you can't spam it, because you have proof of work showing I've done work to validate that this is valid data. And proof of stake, you don't have that. We did a Canada-wide banking prototype with ZK, right? It was on Hyperledger, but it was basically like an app you download, and they were tied to the government as well. So a big bank out in Alberta, Canada, they were tied to the government, and every passport and every ID was digital ID, DID, right? And they did credentials. So the government signs a credential to the user, it goes into their wallet, and they have a credential. Now I go to the bar and I want to prove I'm over 18. So you on your own app calculate a ZK proof to prove that the credential says you are over 18, and you give it to the bartender. The bartender never learns of your age. He just learns you are over 18. But he checks that the credential has been signed by the government. So this is how ZK proof, don't give up the knowledge, but you give up the fact that you check something. Applying it to blockchain is a little different, because we can avoid recomputation. Remember, we want to avoid recomputation. So that one it's going Canada-wide, so that was big. But the ZK was, proving you know something without exposing what that data is, right? And I can give you information, you can verify it yourself. But applied to blockchain, ZK-Rollup means I am computing the proofs. I check for double spend of every transaction offline, and I create a validity proof. The validity proof goes into the blockchain, and the blockchain only checks the proof, which is very fast, to prove that 1 million transactions have checked double spend, but they don't even know what those transactions are. So that's why it provides economies of scale. Well, first of all, I think all of those monolithic chains, BNB, FTM, Solana, they're all going to have problems when Ethereum is showing it could scale. The whole USP for them was cheaper fees, right? But now Ethereum with modular roadmap the only fee you're paying is for data availability. It's very cheap, especially when they have proto-dank sharding and EIP 4844. So once it scales, there's no need for some of these other chains. We can, just like the playbook of Avalanche and FTM, they did DeFi clones and then provide ecosystem funding grants, and we're doing the same. It's a playbook, right? And it will slowly grow, right? Organically grow. Once developers know it's a stable environment, and there's buyers there, there's sellers there, there's merchants there, SYS Labs is there promoting it, gaining traction. It'll be we're not going to compete with Ethereum or anything overnight. It's one of those things where we'll build bridges, we'll build interoperability, we'll push Ethereum. We think Ethereum roadmap's great because it's the same as ours. The only difference is the security blanket at the bottom of the stack. That's the only difference. So we are maximalists of Ethereum's roadmap, we're maximalists of Bitcoin security, and we're just putting both of those together. Like Polkadot tried to do what Ethereum is already doing with the rollup-centric roadmap, but they didn't get the data availability part, which took time to figure out. We needed rollups to go on mainnet to understand there's a data availability problem to solve it, right? Polkadot tried to go ahead of Ethereum and let's modular blockchain, but they forgot that, there's a big component missing, data availability. So I think we have to take a step back there and realize that maybe Ethereum is is the roadmap of Polkadot, but done in a better way. But Polkadot is great in its own regard, in that there's a bunch of stuff happening. Celestia is there, there's a data availability there, and then the IBC is connecting so many different things. That's a viable ecosystem. It's growing exponentially, but in the end, it's still monolithic. One validator or a set of validators proving everything. If there's many new chains, the exponential cost adds up on those validators. Whereas on Ethereum and Syscoin, layer one doesn't even know or care what's happening. It's just a validity proof coming into a smart contract. There is no exponential cost happening, filter back to the base layer. As Uniswap affected trading, the AMM model, we took that and we built it into the existing DAO structure to take away governance and take away speculative token. And we're actually taking that idea and building it into a corporate governance model where if you're a bank, you are a user, you do LP position into the smart contract and you take a rebasing loan against that. It's like what AlchemX V2 is doing, right? AlchemX V2, the takeaway is the time value is the only risk. If you have money, you could lend against it and get someone to build something. And then time value in DeFi is covering your loan. And we're doing this in SYS Labs. We're doing this our core corporate structure to create a recursive effect to build our ecosystem. And we've modeled out in Monte Carlo simulation that we can make $7 million a month or $100 million a year, keep recuperating back into the ecosystem, and the loans are paying themselves off. There's no counterparty risk. So that's an example of taking like the idea of Uniswap and turning it into something greater, into DAO, right? But as Professor Dan Bonet said of Stanford, every time you scale up 10 times, and by the way, we're scaling up way more than that, you get 50 to 100x new use case, because people don't have fee challenges. They don't have 2 second delay, less than 2 second delay. It opens up new use case. I think ZK is going to open the doors to smart cities, IoT, and AI, right? But the ZK is what's interesting. So anyone doing ZK is going to be interesting. So all the investments are coming into that space. So Metaverse, GameFi, and Web3 is all intersecting with ZK. I think Metaverse is a buzzword. There's no such thing as like an immersive experience. Like that's just a game. That's just Roblox, right? But Metaverse will be like you're in real life and you can sense that there's a QR code, you scan it and interact with that in the digital world. You know what I'm saying? Like it's real world interacting in the digital world. That's the Metaverse. Cardano is great for the UTXO model, right? They're formal proofs on doing things in the right way with UTXO. The problem with Cardano is they don't have a model for data availability. It can change. If Charles realizes that the roadmap requires data availability, he'll realize that. But they're a little bit behind because they're still focused on state channels. And this is coming directly from research teams working on Emergo and Orbis, the Orbis ZK-Rollup on Cardano. Great, UTXO is great. Privacy, parallelism, awesome. It suffers from standardizing. It's not Web3. It has new programming, all this stuff. But you can't do AMM Uniswap. You have to build something new. That's the problem. But you have to still have data availability. Once they do that, though, it's got legs. I think it's interesting. But as of right now, maybe they get there, maybe they don't.